Okay, so to complete this question, I've got a sample mean, that's an x bar of 234. And the next thing I need is a sigma. Well, I've got the standard deviation of the weights of the 50 potatoes, so I'm going to have to make do with this 25.1. So that's what I'm having as my sigma. And then what do I need? I need an n. How many potatoes in the sample? It's 50. So then is 50. And now we have to do our Z calculation. So we said before that for a 95% confidence interval, this will be 0.95, which means that I'm going to have 0.025, the other 0.05 split into 2, hanging off each end. So I'm going to look up P equals 0.025 using normal inverse. Okay, is a simpler one to do, but of course it's going to give me the negative Z score. So when I do that, I need to go into distribution mode, I need normal inverse, and I want an area of 0.025, and it tells me my Z score, which is minus 1.95996, so that's minus 1.960, so Z equals minus 1.960 for this value of P. This will be plus that same one, so I'm going to take Z equals 960. Okay, so I've now got the four things set up for my confidence interval formula. So the X bar was the 234, so it's going to be 234 plus or minus the 1.960 times the sigma 25.1 over root n, so that's over the square root of 50. Okay, and my confidence interval is therefore, I've just got to do these values on the calculator, and it turns out that I get to the three significant figures, I get 227 and I get 241. And I should say this is grams. Okay, so that was part A, and then in part B, I've got to say why the sample won't be random when we do what? When we let the customers, where is it? They are allowed to choose any 5 potatoes for £1. So what are they going to do? They're not going to be random. They're probably going to choose something like the largest. I'm going to put potatoes. Whoops. Or you could say they will choose potatoes of similar sizes or whatever, but something that is going to be non-random in terms of the weights of the potatoes. Alternatives are allowed, but larger size of potatoes is the most obvious one to go for, I think. Okay, I've got a sample of 50 potatoes from a large batch. The weights of the 50 potatoes have a mean of 234 grams and a standard deviation of 25.1 grams. Now this mean is a sample mean, so this must be a value of X bar. And now I need a 95% confidence interval, so I know what the method I need is. As soon as I see confidence interval, I know that I'm going to need the confidence interval recipe. And you need to remember this recipe, X bar plus or minus Z times the standard error, which I've just given you this time. So you fill in the given values of X bar. You've got X bar. Sigma, we don't have the population standard deviation for sure, but you've got a sample standard deviation, which is a good estimate for sigma, so you'll need to use that. N will be the size of the sample. That's been stated in the question. So we just need to find a Z value. So remember, your Z value always comes from the percentage, and for a confidence interval, we always want the central percentage. Okay, so 95% in the middle. So put a probability in there, work out the probability hanging off each end. So this probability here, you can look up, remember your calculator on normal inverse needs a probability to the left. So if you put this small probability in here, you'll get this Z value and it'll be negative. If you work out this total probability and you get this one, then you'll get the same Z value but positive. Either way, we just need one Z value here. Once you've got these four things set up, you put them in with the subtraction first, then you put them in with the addition, and you're going to end up with your confidence interval. So you're going to say that this equals a value plus or minus substitute your numbers in, and then all you need to do to finish off your solution is to quote your confidence interval in square brackets. So that's what your solution will look like. Okay, and then in part B, it's just a one marker. We've got to say, so most of this is reading it, so they're purchased, he sells them to customers, they choose any 5 potatoes for £1, and we've got to give a reason why this is unlikely to be a random sample. So you need to think about not just a definition of random, you need to think about why in this particular case there would be some reason for customers to choose something other than a random potato. So you need to give a reason of the form. It's unlikely to be random because customers will probably choose, and then just say, using common sense, what you think they will do that isn't random.